there and welcome. This is Aurora with Supercharged Math, and we are going to do an algebra class today. Remember, during our algebra class, this is an Algebra 1 course, and we are taking 2 weeks to cover each session. And in our algebra series, which is, let me show you where I am, in the math program, if we click on algebra, oh, you can't see, sorry about that. If we click on algebra here, you'll be able to see there are 7 sessions that are outlined, not fractions, algebra session number 1, number 2. We just completed, we had 2 weeks in each of those, and now we are starting algebra session number 3. We're going to be in rational numbers and inequalities for 2 whole weeks. So if you want to know what the schedule is for the live class series, you simply go up to grades 7 and 8 up near the top. Oh, and it looks like I am each of those, and now we are starting algebra. There we go. Okay, and what you're going to do is you're going to scroll down, and it looks like I'm missing my mouse. Let me get my mouse back. There we go. And then do you see the live class series is here? So you can participate live or you can watch the recording. Either one is totally fine. So I just want to make sure you know what the live class series is. And so if you're going to be doing the program with us and keeping up live, that's great. If you find that you start keeping up with us, but then you want to take more time because, hey, education is not a race, that's totally fine as well. You want to take your time with this and know that you can take as much time as you need to. I do know in that algebra series, there are between 40 and 50 videos a week in each one of the sessions. I'm sorry, not in a week. 40 to 50 videos in every session. So that's why we're taking 2 weeks. Some of those videos are like 40 to 50 minutes long. So we want to make sure you go slow, that this stuff makes sense, right? That you're having a happy, positive experience and not getting too stressed out. You will want to keep up with the work. And so I would say between 30 to 60 minutes a day, 4 to 5 days a week, is more than enough to do the activities, the projects, and you're not just sitting there doing workbook problem after workbook problem after. There's some workbook, but then you're going to be building stuff. And you're going to be creating solutions to things, and you're going to be solving real world problems from like astronomers. And today we actually have physics and chemistry labs for you as well. So we're going to have a lot of practical application stuff, and I want to make sure you have enough time to do those as well, so to really, really get into it. Okay, so if you are new to the program, welcome. We are diving into real numbers, or not real numbers, rational numbers today. And if you have questions as we go through the program, what you're going to do is you are going to let me know either by email or typing it in below on the box. If there is no chat box because you're viewing me on something that doesn't have one, what you're going to do is you're going to send me an email, aurora@superchargedscience.com, so I can answer your questions as we get going. All right, and it is right on the nose, 10 o'clock. Let's get going. So, let me get my slides up and ready. If you guys want to give me a quick shout out, tell me where you are. I can say hello to you. We had a whole bunch from before, and I can give you a shout while everybody is getting online and getting ready. And I do have a story for you. Excellent question. Yes, of course I do. You have to earn it though. Yeah, you have to earn it. All right, so we have... So we have North Carolina, hello, Atlanta, we have some Californians, we have some Texans, hello, Missouri, Minnesota, Alaska, Nebraska, Oklahoma, Utah, hello, UAE, oh, wonderful, you are definitely calling from a long ways away. We have hello to the Philippines, Singapore, hello, hello, India, hi. So we have a lot of families on, a lot of kids from around the world. Why don't we just dive in and get started? So remember, what you'll need today for your class is your notebook and a pencil. And there's nothing else yet. Okay, that's all you need. Just a notebook and a pencil. Should be pretty easy. If you are ready, rub your hands together. Give me a great big, oh yeah. And here we go. Hello, everyone, and welcome to Algebra session number 3 in rational numbers. And we're going to talk about what a rational number is, and we're also going to start our conversation on inequalities. If you ever felt like something wasn't fair, well, I guess that's one way to think of it. Right now, can you get your calculator for me? Do you have a calculator? If not, you can borrow mine. But I thought we would do a quick little activity before we actually get started. So let me bring you down to my desk. All right. So calculators, they're really useful, right? We can turn them on. We can say 3 plus 4 and get the right answer. Yeah, would you agree? Okay. Can you say 4 times 5? Okay. Now, I want you to say a number, say 20. Now, I want you to divide it by 0. What do you get? Yeah, there's some things a calculator just simply can't calculate. All right, let's try another one. Can you put in, if yours has sine, cosine, tangent, can you put in, let's say 90 and then, oh, here, we have to clear that. 90, oh, and then say sin for sine. Okay, I get a 1. Put in a 45 for cosine. All right, I get a decimal number, kind of a scary looking one. Good. All right, I'm going to put in 90 and then I'm going to hit the word tan. Uh-oh, there's something else it can't calculate. Okay, and it's not just that tangent, because tangent will give me like numbers, but for some reason, there are certain things that tangent, T-A-N, doesn't like. Huh, all right. So we can't divide by 0. We can't take the tangent of 90, okay. Don't worry about what these things mean. We're gonna get to that in geometry. Here's another one. Can you put in a -1 for me? Put in a -1, it's gotta be negative, okay. Oh, actually, here, let's just put in a positive. Put in 25. Can you put in 25? Now hit the square root button. Did you get a 5? All right, now put 16 and hit the square root button. Did you get a 4? Good. Now I want you to put in a -1 and hit the square root button and tell me what you got. Can it do it? No. So there are some things that your calculator is not going to be able to calculate, and it's not because it's not smart. It's because there are different ways of approaching those, like dividing by 0. And the square root of -1 gets you into something called imaginary numbers, which is not within a calculator's capability, at least this calculator's capability. You have to use calculus to figure that out, and other things. So I just want to point that out. So if you get errors or something on here, if you're wondering like, well, why would we ever want to do that? Well, there are things, that's one of the reasons we study math and we don't just pull out a calculator, because calculator, it's just a tool. It's like a hammer or a screwdriver, right? So we want to use our calculator, but it's our brain that's the main tool. And our calculators we use, you can use a calculator because you're in algebra, for certain things as well. Okay, so let's say, for example, I want to talk about real numbers. So what's a real number? Okay, so give me a number that you think might be real while I'm pulling up my notes for you guys. A number that might be real. 1, good, 1 is a real number. Okay, what else is a real number? What else can be a real number? Okay, maybe 2, all right. How about 1/2? Is 1/2 a real number? Actually, it is. That's a real number. Oh, wait a minute. Did I say real number? Can I start this again? You ever like get stuck on one thing and then you mean something totally different? Can we do this again? All right. Hi, everyone. Today we're going to talk about rational numbers. We already covered real numbers a long time ago. Okay, let's talk about rational numbers. What's a rational number? Okay, so a rational number is a number. So we are talking about, I'll even write it down. So sorry about that. We are talking about rational numbers. Rational numbers. Okay, what is a rational number? A rational number is a number that you can express as a ratio of an integer over another non-zero integer. Okay? So 1/2, this is an integer, 1. Another non-zero integer, 2. So 1/2. So this is a rational number. How about 37? Is that a rational number? Sure, because I can always put it over 1. Good. How about 1/7? Yep, that's a rational number as well. Okay, good. All right, how about 11 over 4? Yep. So how about 0.5? Sure, I could convert that to a decimal. I'm sorry, the decimal to a fraction. And yeah, I can express that as a ratio. So this is expressed as a ratio. Okay, rational numbers are a ratio of an integer over a non-zero integer, right? And that's why we did the calculator thing. All right, there's also something, what if I have a number like this that goes on forever? This is a rational number because it has a repeating decimal. So repeating decimals are also rational numbers. This is also what happens if you take 1 and you divide it by 3. You get this, okay? So if I get say for example, I have another one, 143, 143, 143. That's also a rational number because this is a repeating decimal. So that would be a rational number as well, okay? All right, you want an example of one that's not a rational number? All right, so grab your calculator and, or borrow mine, hit the pi button. As far as we know, there are no repeating decimals in here, and this cannot be expressed as one number of another. We can approximate it, 22 over 7, that's a good try, but it doesn't quite give us the actual value of pi. So pi is an irrational number, okay? So that's just an example of one of them. So if you have a number that is a decimal that doesn't have a pattern at all and keeps going, these both are irrational numbers. And they have special properties that we talk about in another class. Okay, so for our class, we're not going to talk about these. We're going to handle those a little bit later, but we're just talking about rational numbers. Okay, so that's as far as I want to go on rational numbers. The rest of the time, I want to talk about this. We're going to talk about absolute value. That's not how you spell value. I'm on a roll today. There we go, absolute value. Okay. Absolute value, if you've never heard of it before, it simply means that on a number line, okay, I have a -4, -3, -2, -1, 0, 1, 2, 3. Okay. So on a number line, if I would like to know the absolute value of 3, I put these big bars on it. Okay, and you want to make it larger than the actual number, so you know that it's not a 1 in front of the third. So this is not 131. This is a 3. Okay, so go a little below the number and a little above. Okay, what does that mean? That means that I want to know the distance between 3 and 0. Boink, boink, boink. Do you see how that's 3 units? Okay. But what if I'm -3? How far am I from 0? I'm also 1, 2, 3, aren't I? Okay, so the absolute value of 3 would be this one. Oh, I should have done this in another color. Here's the absolute value of -3 is also 3. So we don't care what the sign is in the middle. We just want to know how far are you from 0. So do you see if I want the absolute value of 2, it's going to be 2 units from 0. If I want the absolute value of -2, it's also going to be 2 units, okay? So basically for us, what we want to know is we don't care about there's no such thing as absolute value equals a negative number. It's always going to be positive, and basically what you do is you take whatever's in here and you just take off the negative sign, and that's your answer. Yeah, it's pretty easy, right? But that's what it means. So it just means the distance between what it is you're trying to find an absolute value of and 0, it's going to be equal just to that distance. Okay, it's like, think of it as 2 points on a map. You wouldn't say, oh, from Utah to Dallas, from maybe Salt Lake City to Dallas, Texas, oh, well, that's going to be -640 miles. No, you just say it's 640 miles. I just want to know the distance. I don't care the direction. Make sense? Okay, so let's do some examples so this makes even more sense. Okay. Can you tell me right now what is the absolute value of -4? What would you tell me? Whoop. There you go. Make it really obvious, because once you get going in algebra, you can have these things in parentheses, all kinds of stuff in the same equation. So make sure you're good at this. Absolute value is slightly bigger than the number. What is this? Yep, it's just 4. That's right. Okay, fine. What is the absolute value of +4? Yeah. Also going to be equal to 4. Yep, that's right. Good, that wasn't hard. How about this one? Absolute value of 7 minus 13. And this is honestly where it comes up more. Okay, so what you're going to do is you're going to do the inside first. 7 minus 13 is going to be a -6, so write your absolute values down. -6, and how far is -6 from the 0 on a number line? It's equal to 6. Okay, so this is equal to 6. Good, not -6, because it's got absolute value bars on it. Okay, so how about this one? Absolute value of 4 minus 1. Okay, do the middle first. 4 minus 1, okay, is 3. So this is going to be the absolute value of 3, which is equal to 3. So anytime, you would never leave absolute value bars in a problem as part of the answer. You would always just evaluate it, okay? So you'll never see this as like boxed in an answer, okay? All right, so pretty simple so far, right? Okay, so hang on to that information, put it on the back part of your brain, because we're going to add something to that, and it's called, these are called inequalities. Inequalities. Okay, great. So what is an inequality? Okay. All right, an absolute value of 0, somebody's asking? Yeah, it's 0. That's right. Inequality means, well, here, let me give you a practical example first, then we'll do the math one. Okay, so you tell me at what is the fastest speed your parents can go legally in your state without getting a speed ticket on the freeway? Okay, think of a freeway and tell me, what is the fastest speed they can go? So is it 55 or is it 65? I know there's one state, Montana. Yeah, you guys don't have speed limits. But I know you can get tickets for reckless driving. Okay, so I know, I'm moving to Montana. All right, no. Okay, so all right, so suppose it's I'll pick one that's being submitted here. 65. So can your parents go 64 miles an hour on the freeway? So nothing strange like fog or snow or anything like that, right? Just regular sunny day, roads are in good condition, right? Nothing unusual. They can go 64, not get a ticket. Can they go 63? Yep. How about 60? Sure. How about 65? Sure. 66, legally. They can legally get a ticket. Are they likely? Probably not. What if they go 100? Yeah, then they're more likely, right? Okay, but yeah, if anything, they can go up to and including 65, but if they go 66, they start to get into a ticket. So 66 and higher is the ticket zone, 65 and lower is the speed that your car can go at and not get a ticket, right? And there are other tickets like obstructing traffic, but you get the main idea of what we're talking about. Okay, so that's the idea of inequalities. So my speed can be less than or equal to 65, and I'll be ticket free. Anytime I start to exceed 65, maybe 65.1, then I might get a ticket. Do you see this? So what is this doing? I'm not saying my speed equals 65. I am saying my speed this is less than, and then the bottom line is equal to. Less than or equal to. So either case, it can be less than 65, so it can be 64, 63, or it can be 65 and no ticket. Okay? If it's greater than 65, I will get a ticket. Do you see how we read these statements? Okay, great. So what does that mean? That means on a number line, which we like to use with inequalities because it really makes these inequalities make sense. Okay, here's my miles an hour. So if it's 65 or less, no ticket in this zone. Okay, in that zone. Okay, 65 or greater, this is the ticket zone. Okay, no ticket is down here, 65 or less. Do you see that? So we use inequalities all the time, and I'm going to tell you a story about later today about when I use them on fighter planes and airplanes, actually. So it will give us a range of allowable situations, allowable circumstances. You can fly your airplane in these configurations, but in this configuration, you're going to have some problems. The plane may not have enough lift being generated over the wing to keep it in the air. So we use inequalities all the time. And unfortunately, when these first get taught in a math class, this is where students in algebra start falling off the bandwagon because they're like, I have no idea what this means. So we're going to take it slow, and I'm going to try to also make sure you understand why this is important. So scientists and engineers, they use inequalities all the time because very rarely will we be able to say for certain, here, let me show you my face, for certain, like, yes, the force has to be 500 pounds on that bridge. No, that bridge is good up until 500. 501, then we start to get concerned because our factor of safety goes down because we've built in, so it's a little overbuilt, because kids jump up and down, so that creates more of an impact, right? Or they bring their dog or a car drives over it and not supposed to. We don't want it to collapse, right? So we have some safety in there. So it gives us a range where things are safe. And then there's you're going to have some problems over here. So smile so I know this is kind of making sense. All right, how do we do the math part of it? Okay, math part is going to look like this. If I say x is greater than 2, what does that mean? That means you can you eat 2 cookies? No, you have to eat more than 2. Can you eat 2.1? Yep. How about 3? Yep. How about 1,000,000? Yep. Okay, so what does that look like on a number line? That looks like this. So I have a 0, 1, 2, 3, 4. All right, because there's no little line under here, so what I'm going to do is I'm going to have an open circle on the 2. That means 2 is not included. Can x be equal to 2? No, because this would say 2 is greater than 2, and that's not a true statement. That's false. But I could say 2.2, right? So anything greater than 2 will make this statement true. 2.2 is greater than 2. Yep, absolutely. 3 is greater than 2. 1,000,000 is greater than 2. So this will go out onto infinity. Okay, let's try another one. What if x is less than -7? Okay, x is less than -7. Let's see what that looks like. Here's -8, -7, -6, -5. Okay, so what that looks like is x, first you find the number, -7 is right there. Because there's no x, if it was equal to or less than -7, then we'd fill that in, but we're not, okay? Because can x be equal to -7? No, because then that would say -7 is less than -7. That's not a true statement. Can x be -8? Oops, sorry about that, hang on. That should say -7. There you go. Okay, so yes, that is a true statement. -8 is smaller than -7, so we know the arrow goes this way. So to figure this out, the first thing you do is you find that number on the number line, and then if there's no little equal sign under it, it's open. And then to find out what direction the arrow goes, you just test. So you could put in -6, and you'd see that's not true, so you know the arrow goes in the other direction. Okay, so you see how to make these? All right, now let's try some where the circle gets filled in. If I said to you x is greater than or equal to 5, okay? So you have a little number line. You should be drawing this too. 4, 5, 6, 7. Okay, so you find the 5, okay? And then what are we going to do? Well, we're going to fill it in because can x equal 5? Is 5 greater than or equal to 5? That's true. So we're going to take that here and then we're going to color it in. Yes, that's true. Okay, what about 4? Is 4 greater than or equal to 5? No, that's false. So we know the arrow doesn't go this way. Here, we'll try another one. 6 is greater than or equal to 5. Yes, that is true. So with inequalities, you just have to test to see which way the arrow goes. All right, how are we doing so far? How are we doing? Somebody's asking about infinity. So infinity we start to use in calculus. So it's a great question. So yes, it does go infinitely long in both directions. That's why there's arrows on both sides. Okay, but just know that in calculus, we're going to start to deal with infinity, and actually we need it in order to do derivatives and stuff. But don't worry about that now. All right, now I want you to try one. Can you do this one for me? X is less than or equal to -4. All right, you do that one. Here, I'm going to do it off screen, and then we'll compare answers. You draw me the number line for that one. Okay. What does that one look like? X is less than or equal to 4. Okay, did you get it? All right, what did you get? Let's see. Did you get this? Yay! Okay, great. Yeah, not that fancy, right? Okay, so we have to try these. Now, I'm going to put this, what we've just done here, together with the number lines and the inequalities, and we're going to combine it with absolute value. You ready? Okay. Absolute value of x is greater than 4. Okay. What does this mean? So the absolute value of x is greater than 4. All right, so let's test. Let's say x is equal to 5. So that means the absolute value of 5 is greater than 4. So that means 5 is greater than 4. Is that true? Yes, it is. Okay. What if x is -5? Okay, let's try it. -5 is greater than 4. The absolute value of -5 is greater than 4. That says, remember, absolute value of -5 is just 5. Greater than 4. Yes, that works. Excellent. Okay, let's try another one. What if x is 3? Okay, absolute value of 3 is greater than 4. You have to test. Let's see. This says 3 is greater than 4. No, that's false. So that's wrong. Okay, and let's do x is equal to minus 3, just for grins. Okay, so the absolute value of minus 3 is greater than 4. Is that true? Okay, this is going to be 3. Absolute value of minus 3 is 3, is greater than 4. Nope. Okay. So you have to test because we don't know. And so we're going to have our number line. Okay, and then I'm going to have my 0. 1, 2, 3, 4, 5. So this is my 4, 5. 1, 2, 3, 4, 5. This is minus 5, minus 4. Okay. 1, 2, 3. Minus 3, minus 2, minus 1. Okay. So what does this mean? This means that for x, x is going to be greater than 4. Watch me now. Important part. X is, flip this, less than negative 4. What? Okay, watch. Because we said x is 5. Yep, x is greater than 4. Okay, so x is 5. So we're going to say this is true. Open circle. Good. This is x is greater than 4. Right? This is an open circle here. Okay. And then, look here. We also said x was negative 5, didn't we? Okay. And then that also gave a true statement. So that's this x is less than negative 4. So this number line has 2 arrows because the absolute value is involved. Okay? Because it's involved, we will have 2, and this is an and. Either one of these will make this statement true up here. Okay? We're going to practice this. We're going to practice this. Okay? So just know that when you take the bars off of an inequality, you simply write the inequality first, and then you flip the sign and write the negative because you need both in order to make that statement true and that statement true. Okay, that's the only way this is going to work. All right, if you're like, huh, this makes no sense. Okay, hang on. Let me back up just a second, and let's take a look at a couple of ones like this. If I said x is not equal to 4, how would you plot that on a number line? I would have my number line, and I would have 3, 4, and 5. I would have an open circle because x can't possibly be 4. Can x be 3? Sure. How about x be 5? Sure. You can be anything you want, it just can't be 4. Right? Your mom says you can have any pie you want except the apple pie that's in the fridge. Okay, so you can have anything you want except that. Whatever you do, not that. Okay, so I'm going to have a double-headed arrow on the entire number line, so all the numbers except 4. 4.1, that's fine. 3.9, fine, but not 4. Good? Okay, if x, somebody asked if x is less than or equal to 0, what does that look like? Okay, so let's do that really quick. Okay, here's negative 1, 0, and 1. All right, so it's equal to or, okay, so we find the 0, right? Because it's got the little line, we color it in. So we're including 0 because it can be x is less than or equal to 0. There's the equal to. X is less than 0, so we know the arrow is going to go this direction. Okay, and it goes all the way down the number line. Okay, let's go back to that absolute value thing. Let's take an easy example. Watch this example. Ready? I want you to write down x is less than or equal to the number 7. Okay. So let's try it. If x is 0, what do we get? We get a 0 is less than or equal to 7. Is that true? Yeah, that's true. So that works. Okay. All right, let's try x is equal to positive 1. So we have a 1 is less than or equal to 7. Yeah, that works. How about x is negative 1? Okay, absolute value of negative 1 is 1 is less than or equal to 7. Hey, those all work. Okay, great. Let's try another one. How about x is equal to 8? All right, absolute value of 8 is 8 Is that statement true? No. Okay, what if x is negative 8? Okay, so we're choosing points around this guy. Yep, so what do you think? And also 0 is a good one to check too. Okay, negative 8, absolute value of negative 8 is just 8. How far is negative 8 from the 0? It's just 8. Is this a true statement? No. Okay, so now we have to put all of this into something that makes sense. So what does this mean? What is the range of values for x that makes this true? So on our number line, that is off the screen, okay? That means the 7, this is negative 7, 6, 5, 4, 3, 2, 1, there's my 0. 1, 2, 3, 4, 5, 6, 7, okay, and onward. This means that the 0 is included, the 1 is included, the minus 1 is included. How about 7? Is 7 included? Sure. If x is 7, 7 is equal to 7, so that's true. So we find the 7s and we color them in. Now, where do the arrows go? They have to include the 0, the 1, and the minus 1. So it's actually not an arrow this time, it's a line segment that starts at negative 7 and goes to positive 7. So the solutions are any number between negative 7 and 7, including those endpoints. Any one of those numbers will work. If I go outside to 8, 9, 10, that doesn't work. That's the no section. Do you see how we have to test it to see when we draw our diagram here? Excellent. Okay, so you have to try it. So, all right, so that means that for us, so do you see how we tried it in here? So what does that mean? That means that x is less than 7, less than or equal to 7. So you just write it down. You take the bars off and just write it down. And then what you do is you write down the x, and then you flip this, leave the equal sign, and then you make this thing negative. Okay? All right? So let's see if this is true. X is less than or equal to 7. X is less than or equal to 7. That's true. Okay, that's in here. The other part I said was x is greater than or equal to negative 7. Greater than means closer to 0, and that's this part. Do you see that? All right, so this is the answer to absolute value. To take the bars off, you have to have both of these. You're going to have 2 solutions to the problem. Anytime you have absolute value, it's because this x can be positive or negative. Okay, so let's try some more so you're comfortable. Okay, let's try some with some numbers. Okay, I know it's a little bit wonky, isn't it? Yeah, so let's just take our time with it so we feel comfortable. All right, so yes, class will be a little bit longer. You're absolutely right. If I said 3x minus 2 equals 7, could you solve that? Yeah, we spent a lot of time on linear equations so far. What would you do? Just tell me what the first step is. Yep, you'd add plus 2 to both sides, and then what happens? We'd have a 3x, and then minus 2 and plus 2, that goes away, equals 7 plus 2 is 9. Now what do? Yeah, we divide by 3. Good. Okay, divide by whatever's in front of the x. Okay, that goes to 1. X is equal to 9 divided by 3 is 3. Good. All right, that looks good so far, doesn't it? All right, I'm going to raise the camera up a little bit so we can see both. Okay. All right. What if the problem is, let's put this right there. Okay. 3x minus 2. And now I'm going to put greater than or equal to 7. How does that problem change? Okay, it doesn't. You actually do it the same way. So our first step here was to say plus 2. You treat this thing like an equal sign. All right, and then you just say, all right, 3x, that goes away, greater than or equal to. Make sure you copy the same sign down. 7 plus 2 is 9. All right, how do we get the x by itself? We're going to divide both by 3. 3 over 3 is 1. That goes away. X is greater than or equal to 9 divided by 3 is still 3. Do you see how the problems are, you solve them the same way? Yeah. Okay. And then if I were to put this on a number line, what would I have? I'd have a 2, a 3, a 4, And then I'd find the number, the 3. I'd put a circle on it. I'd color it in because of the equal sign. And then x is going to be bigger than it. So it goes this way. Good. How about this one? On a number line, 2, 3, and 4. There's your solution right there. X can only be 3. You can only have 3 cookies. That's it. You can't have 4, can't have 2. This is Grandma's house. Oh, you need at least 3. Right? All right. So good. All right. So we're good so far. Okay. So there's one little exception to this rule. One little exception. So what we wrote down was accurate. That is correct. Okay. What we did so far, there's one exception. If there's a negative sign in front of the x, anytime you multiply or divide by a negative sign, you have to flip. Very much the same way we did with the absolute value. So let me show you what that is. Okay, let me show you an example. Good so far? Yeah, you like that part. Okay, I'm seeing some comments saying that was a lot easier than I thought. Okay, great. So let's do this step by step. If I have, you solve them the same way. So if I have, let's choose an easy one. Okay. All right, so the rule is that you're going to flip the inequality sign when you multiply or divide by a negative number. Okay, so anytime that you do that, then and I'll show you why you need to do that, or why that's obvious, or sorry, why you actually have to do that. Let me show you. So the first step here, if this was an equal sign, this would be easy, right? You would just divide both sides by whatever's in front of the x, including that negative sign. Okay. All right, so this would be an x, but see, we have to flip it because we're dividing by a negative number. So it means you're going to do this. 14 divided by negative 2. There's only one negative sign, so it's a negative. 14 over 2 is 7. There is your solution. Okay, so this has to be greater than 7. So on a number line, here's 6. Oh, wait a minute, negative 7. Let me change that guy to a negative 8. Negative 8, negative 7, negative 6. Okay, so you find the number. We don't fill it in because there's no equal under it, okay? And then it's got to be bigger than negative 7, so that means it's going to get closer to 0. Okay, so if you don't do this, you actually change the problem. You change the problem, so if you don't flip it. So you'll get a yes when it should be a no, and a no when it should be a yes, and so you basically are breaking the math rules. It's like saying 2 plus 3 is equal to 15 now. And you're like, wait, you can't do that. So just remember, you're going to flip the inequality sign anytime you multiply or divide by a negative number. You can add and subtract all you want. Okay, so let me practice this so you can get good at this. So you can get good. Okay. All right. So if I have an equation that looks like this, if I have minus 3x plus 2 divided by 4 is less than or equal to 2. This is about as hard as the problems are going to get this week. Okay. So what's the first thing? If this was just an equal sign, what's the first thing you would do? What's the first thing? Go ahead and tell me. Tell me out loud. Yeah, you'd handle the 4 first, right? Because it's locking up this minus 3x plus 2. So you're going to multiply both sides of the equation by 4. Okay. So these 4s are going to cancel. This is a positive number, so I don't have to flip anything. I'm going to rewrite it as minus 3x plus 2 is less than or equal to 2 times 4 is 8. I'm going to say minus 2, minus 2. Here's a trick question. Do I flip this sign? No, because I'm adding and subtracting. So do not flip sign for addition or subtraction. Okay, do not. So write that in your notes. Do not flip sign for addition or subtraction. So this is going to be a minus 3x is less than or equal to, this goes away, 8 minus 2 is 6. Okay, so that's this one. All right, now we got to get the x by itself, so we're going to divide by a minus 3 and a minus 3. Okay, now what's going to happen? Yep, that's right. We're going to have to flip it, aren't we? Okay, so this is going to become just x on this side, and you just write it the opposite. You keep the equal sign. 6 divided by 3 is 2. There's only one negative sign, so now that becomes a negative 2. Okay. All right, so what does this look like on the number line? Okay, so I'm going to have a minus 2, a minus 1, a 0. Okay, so we find the number, the minus 2, and then we color it in because it has the equal sign, and then it's going to be bigger, so it's going to be closer to 0. And past it. All right, so so we do flip here, flip sign. So write this on your notes. We're going to flip the sign so it looks like that. Okay, all right, so basically when we're dividing by a negative sign, we're flipping the relationship over the 0 on the number line. So a number that's larger when positive gets more negative and smaller when it's negative. So you'll see this more when we do more with absolute value. Okay, so the reason is because we're flipping the relationship. So if we didn't flip it, now we've got the wrong relationship between the two. Okay, and you can actually try this. So if I have x is, so if I put let's see, if x is equal to negative 2, and I put a negative 2 in here, then this will become a true statement. If I didn't flip, I would have x is less than negative 2. So if I put a number like minus 10, I'd put this in here and I'd get a false statement up at the top. Yeah. All right, so make sure you're flipping the sign only for multiplication and division for inequalities. Do not flip it for plus and minus. All right, how are you feeling so far? You want a few more problems? All right, I've got lots of practice problems now. Ready? Here we go. So I have a 2x minus 1 is greater than 5. All right, let's practice. 2x minus 1 is greater than 5. What's the first thing we do? We add 1 to both sides. So I have a 2x is greater than 5 plus 1 is 6. Okay. Then we're going to, just like this was an equal sign, we're going to divide by whatever's in front of the x. And I'm going to have an x is greater than 6 divided by 2 is 3. Notice the sign did not flip. The sign did not flip. Okay. All right. And I know you want a sign that flips. Okay, let's do one. How about 6 minus x over 2 is less than or equal to 4? Ooh, doesn't that look like fun? All right, I'll leave this one up so you can kind of see it too. All right, so we're going to multiply both sides of the equation by 2 first, okay, to get rid of that. So I'm going to multiply by 2 and multiply by 2. So I'm going to have the 2's cancel. So I have a 6 minus x is less than or equal to 4. Oh, no, not 4. That's an 8. 4 times 2 is 8. There we go. Okay, so I have, let's see, a minus 6, a minus 6. So I have a negative x is less than or equal to 8 minus 6 is a 2. I'm going to divide both sides by, or multiply both sides by negative 1. So I'm just going to go negative 1 and negative 1. Because this is negative, we're going to flip it. And this is a negative 2. Okay, x is greater than or equal to minus 2. All right, watch this. Do you see this part here? I'm going to rewrite that equation. So 2 times 6 minus x over 2 is less than or equal to 4 times 2. I'm just rewriting this part here. Okay. All right, so this cancels. All right, I have a 6 minus x is less than or equal to, and 4 times 2 is 8. Okay, same thing here, right? What if I put the 8 over here and I put this over there? See, I'm not going to flip the sign because it's addition and subtraction. So I'm going to say plus x, and I'm going to say minus 8, minus 8. What do I get left? 6 minus 8 is a minus 2. Plus x and minus x, that's a 0. I just write down the sign. I don't flip it because I'm just doing addition and subtraction. 8 minus 8 is 0, and plus x. Do you see how they're the same? Do you see how they're exactly the same? This says x is greater than or equal to minus 2. X is greater than or equal to minus 2. The written left to right is inverted, but it's exactly the same. Yeah, they're exactly the same thing. Here, I'll show you on the number line. So this is minus 2, minus 1, 0, and 1. Okay, so the minus 2 is here, and it's filled in because of the equal sign. And x is larger, so it heads, the numbers get bigger, so it heads towards 0. Good. Do you see how we have to flip this in order to maintain the relationship? If we didn't, now x would be smaller than 2, and you'd get all the wrong answers. You'd actually get the range that it's not true for, and that it reverses. So you have to keep them the same. All right, you want me to leave that up for a second? Sure, I can leave that up. Okay, great. All right. Okay, I want to have infinite cookies. Oh, Ivory, I think that's a great idea. Yum. Okay, are you okay if we do a few more problems? You okay if we practice a few more? Okay, because I have some more that I want to do. Because I want to make sure this is really making sense. Okay, so if I have 7 minus 2x is greater than 3 plus 4x. Sometimes you have problems where there are x's on both sides. X's on both sides. Okay. So you can decide where to put the x. So you can bring the 4 over here or put the 2 over there. So I'm going to add the 2 because then I won't have to divide by a negative number. Okay. So I'm putting the 2 over here, and I'm going to put the 3 over there. And to do that, I'm going to go minus 3, minus 3. So remember, whatever you do on one side, you've got to do on the other, and the 3 and the 3. You got it. So I'm doing 2 steps in one. Are you seeing that? So get the 2x, the negative 2x over here becomes positive 2x. 4 plus 2 is 6x. Okay. Write down the inequality. 3 minus 3, that's going to be 0. Minus 2 plus 2 is 0. 7 minus 3 is 4. Good. And now we're just going to divide by whatever's in front of the x. Okay, so x is less than or equal to, and I'll just reduce the fraction to 2/3. There. Good. So how was that? Does that feel good? Okay, yay! This is what you should be right now. Yay! All right, if you're still getting stuck on this alligator symbol, this greater than or less than, just pretend it's an equal sign and solve the problems exactly the same. There's nothing that changes. The only difference is you have to account when you divide by a negative number or multiply because it changes the relationship that x is from the 0. Okay, so let's try another one. You want to try another hard one. Okay, how about negative 3x is less than or equal to minus 21? What if everything's negative? Okay, so what would you do first? You tell me out loud. What would you do first? Yep, you divide by, no, not 21. You divide by minus 3. Yeah. And then you're going to flip that. Okay, so let's do the work. Minus 3 over minus 3 is 1. So x is greater than or equal to, now there's 2 negatives here. That means positive. 21 over 3 is 7. X is greater than or equal to 7. And then look, watch. Can x be 7? Yeah, because that's what that little minus sign, or not minus sign, that's what half of the equal sign means there. Sometimes you'll see this written as like this, and that it means the same thing. One line or two, it just means equal. Okay. Let's see. And so x is, so if I said, let me use another color. So for x equals 7, this statement should be true. So minus 3 times 7 is less than or equal to minus 21. I have minus 21 is less than or equal to minus 21. And that's true. Good. What about x is equal to 10? So that's minus 3 times 10, which is minus 30, is less than or equal to minus 21. So I have minus 30 is less than or equal to minus 21. That's also true. Yeah. Yeah. So plugging it back in will triple verify that you got the right answer for the problem. And this is actually what I do on exams, because that's where I get nervous and I make the most mistakes. So what I will do on tests, reviews, exams, I will actually plug numbers in to make sure I didn't make a mistake with the inequality sign. Yeah, it's a good practice to get into, especially in algebra. Okay. How about another large one? How about 3x minus 4 is greater than 5x minus 8? Okay, so you have a choice here. You can bring the 3 over here and keep everything positive, and you won't have to flip the sign, or you can bring it over here and make it negative and flip it. So let's do both. So this one will be, I'm going to say minus 3x minus 3x, okay? And then I'm going to say plus 8 plus 8. So let's add everything together. So this goes away. 8, so this is a 4 is greater than, and this is 5 minus 3, which is a 2x, and then this is nothing. Divide by 2, I have an x is less than 2. Good. You want to try it the other way? Okay. So let's say we do this problem again, but this time we are going to say, let's see how do I want to do this so you're not distracted by the calculations already? Okay. So this is going to be a minus 5x and a plus 4. Okay, so what do we have there? So I'm going to have a minus 5 plus 3 is a minus 2x. This goes away. This stays here because we haven't divided by negative sign. We've just been adding and subtracting, okay? This goes away. This is minus 8 plus 4 is minus 4, okay? So I'm going to divide both sides by minus 2, okay? So then I'm going to have, this is just going to be x. Remember to flip it. And 4 divided by 2 is 2. 2 minus signs make it a positive. Okay, and then we have, if I fold this in half, we have exactly the same answer. X is less than 2. Good. I know, so it's okay to do either one. So in this case, what we did is we made it so we didn't divide by a negative number. This one we divided and we had to flip the sign. This is just what I want you to see. We had to flip it. This one does not get flipped because we didn't divide by a negative number here. Good. All right, so you want to do more with absolute value. Sure. Yeah, no problem. Okay, so first let me pause for a second because we've been rolling for a while. Have you noticed that? We've been going for a while. So can you stand up and shake it out a little bit? All right, so I have a number of questions that have come in from students. That was as far as I was going to go. What I'm going to do now is just answer some questions. I'm going to do some absolute value problems. So very similar to what we just did, but I'll do some absolute value as well. All right, get a snack, take a bite. All right, let's go for, let's say, another 10 minutes, doing a couple more problems. Ready? A couple more problems. Okay, so let's say I want to do absolute value of x minus 7 is less than 3. How do we do that one? Okay, because that one's going to come up in your workbooks for the next 2 weeks. Okay, so what we're going to do is, actually before we do that one, let's refresh because we've been doing a lot. Here, absolute value of x is less than 3. What does that mean? Let's just do that one. This means x is less than 3 and x is greater than negative 3. Okay, because x can be positive or negative inside these bars. So the solution has to include both to cover these cases. Okay, so what does that mean? That means on a number line, this one, x is less than 3. So here's our 0, 1, 2, 3. 1, 2, negative 3. Okay, so that means x is less than 3. Okay, so it's going to go this way. And x is greater than negative 3. Greater than negative 3 means this way. So we're actually going to color in between these 2 points. Okay. All right. So this one is what we're talking about on this side, and this one is this side. So can x, oops, sorry about that. That was my battery pack. There we go. Can x be equal to 4? No, it can't. How about negative 4? No, because negative 4 turns into a positive 4, and then that's not true. Okay, so it has to be both. So remember, this thing here, absolute value, is the distance from 0 to whatever it is you're evaluating. Okay, and we just care about the distance. So let's go back to this problem. So what does this mean? So what you'll write down now is x minus 7 is less than 3, and x minus 7, flip the sign, and then put a negative 3. Okay, so both of those have to be solved now. It's not just one. So anytime you see absolute values, you should be thinking, oh, two solutions. Okay, so you're going to have to break this into what we call a compound inequality. So it's got two parts, compound, like homework. Put it together, homework, compound word. Same thing here. Okay, so do you see how this unit is the same here? X minus 7 is the same as that. So I can rewrite this, see if this makes sense. Okay, x minus 7 has to be less than 3. I just rewrote this over here. And I'm going to write this over here. It also has to be greater, this thing has to be greater than minus 3. So here's a compound statement that includes both of them. Do you see that? I don't know if you've seen that before. Okay, so what is x? Okay, so you can actually solve, have you ever solved one of these before? So what you do is whatever you do to one side, you have to do to the middle and the end. So I'm going to get rid of this 7, so we get x by itself, plus 7 plus 7. So this is going to say minus 3 plus 7, that's a positive 4. Bring down the inequality, x, this goes to 0, inequality, 10. Here's the solution. So you can solve each of these separately or you can solve it together. Okay, I just put them together into one statement that was true. So I just wrote this straight down here, okay? And then this is the same as this, and now I put this statement in here. Oh, wait a minute, I have that backwards, don't I? Let me say that again. I put this statement, x minus 7 is less than 3. I put that here, this guy right here. And then this statement here, I was pointing to the wrong ones, okay, is greater than minus 3. So I just put the statements together and then solved, okay? And you want to know what it looks like? Sure. So on a number line, okay, I would have a whole bunch of numbers. Okay, the ones I'm interested in is the 4, which is here, and it's open because there's no little line under here, and 5, 6, 7, 8, 9, 10. Okay, so my solution is right here. So that's what that would look like. Good. Now, this is why we're taking 2 weeks for this session, because I want you to have lots of time to get comfortable with these ideas. Okay. All right, I'm getting some requests from students. What is the absolute value of greater than 2? What does that mean? Okay, so remember, this can be plus or minus. This is x is greater than 2, and x is less than minus 2. So on a number line, this is minus 2, minus 1. Here's the 0, 1, 2. So on a number line, this means x is greater than 2, which is that way. X is less than 2, which is that way. Good. All right, let me just answer a couple more questions that are coming in. Can you solve individually instead of putting it all together? Sure. All right, last thing we're going to do. And then you guys need a story, don't you? I think you do. Okay, last one. Here, let's just do this real quick. So what I want you to do is I want you to write this down, x plus 3. Just write the thing down without the bars, okay? And x plus 3. Now here's the weird one. Flip it and put the minus sign. You see the difference? Okay, so this was the main one. And because it's got absolute values, we're going to have 2 of them now to come out. 2 of them. Okay, so we're going to go minus 3, minus 3. This one is minus 3, minus 3. And these are easy, right? This goes away, greater than 5 minus 3 is 2. This goes away, x, and this is minus 8. So we don't flip the signs. We're not dividing. Okay, so we have two solutions. Two solutions. Okay, on a number line, you wanted to see that too. I see that in your notes. Okay, so this is, how do I want to do this? We'll put 9 minus 8, 7, 6, 5, 4, 3, 2, 1. There's my 0, 1, 2. Okay, so here's the 2, and it's bigger than it. And here's the 8, and it's less than it. Good. All right, so, oh, sorry, you can't see that, can you? There we go. Is that better? All right, yay, we did it. Whew, did that feel like a lot today? Okay, so yes, so we went for almost an hour. Wow, that was a lot to handle. So do you want me to leave this up for a second? Sure, I can do that. All right, so go ahead, and I did 3x minus 2. Oh, did you do a problem on your own? Good, you made up your own problem? Excellent. Okay, good. I'm glad to see that. All right, so let's go back to my face. There we go. Hi. If this was a lot and you're like, please don't give me any more. In fact, I see a student even said that. So no problem. I'm not going to give you any more. Now it's time for you to stand up, shake your body out. That was intense. That was a lot. And my guess is you are ready for a break. All right, so go ahead and grab a snack while I show you what we are going to be looking at. So give me a second and I will pull this up. There we go. Okay, so here's, oh, there's me. All right, so here is the live stream, okay? And so I got here by clicking on grades 7 through 8 right up here, okay? This is where you find the class today. And then, do you see the schedule down here? Okay, so what you do is we're in week number 5, rational numbers and inequalities. And so if you click on that, you'll go straight to algebra session number 3. So we're not in session 5, we are in week 5, but remember we're taking 2 weeks to cover each session, so you have plenty of time to just work with the content. Okay, so you can also get there by hovering on the word algebra and going down to session number 3. Okay, so this is the parent video at the top. This is the video where parents get to see what you're doing this week. You can download your math assignments outline. See that button right under the parent video? Okay, and so you're gonna open that up. Now, if today was like, ooh, that was a lot, that was new. I need more time with this. Don't give me anything new. Okay, so what you're going to do is you're going to go up and you're going to do your algebra workbook called Rational Numbers. Let me show you where to find it. So you go up to the word here, it says workbook, open it up. Okay, workbook. And you're going to scroll down till you see the word algebra. And it is the one in algebra set number 2. Set number 1 is pre-algebra. Okay, so go down to the actual algebra. And we are the second workbook down, rational numbers. Okay, so you'll click on that, you'll open that up, and you can choose to, there you go. You can choose to print this out and work through it, or if you'd like, you can just look at it and then write your notes and your answers in an actual journal. But this is meant to be printed out if you'd like to. Okay, and then once you've done enough work, suppose you start on the workbook and you're like, oh, I am so lost, I don't even know what to do. No problem. Go back to algebra session number 3 and then scroll down. Do you see where it says download your workbook? Okay. And then do you see where it says algebra workbook, rational numbers? I have created my step-by-step instructional videos of me going through that workbook step-by-step on every single page. So if you need more time in class with me, doing more sample problems, working through the workbook, there is a step-by-step instructional video to do that. This one's about 40 minutes long. These are the next pages. This one's also about 45 minutes long. So, and you're going to be hitting the pause button in that as well, because I'll say something, okay, I'll say like, here's a couple of problems. Now hit the pause button. I want you to try the next couple on your own, and then let's compare answers. So it's very interactive like that. So that gives you extra practice with me. Okay, great. And then there's also a converting units for rates and units, converting unit section in there. Okay, if you also, some people were maybe a little unclear of what all these recordings were. So today's recording is going to wind up to be right below the parent video. See the parent video there for parents? Okay, so today's video, the whole hour long, is going to be right under there. And then, do you see where it says beginner? Okay, so these are live sessions from last year. So if you find like, ooh, I wish Aurora would have gone another hour, or I wish, maybe, I wish I had more time with that class, but different numbers. I don't want to see the same numbers again. So these recordings are from last year. So you can look at it. It'll say math lesson. That's how you know it's a lesson with a teacher. And then you can just watch this one. This one's about 40 minutes long, and I'm going step by step. Maybe there's a different way I'm explaining it in this video that would make more sense, that would help you some more. So if you need a little bit more teacher instruction, those are in there as well. And because the classes were so long last year, I actually broke them into beginner, intermediate, advanced. So intermediate is, yeah, we've got the concepts down. Now we're going to do more problems that are a little bit more difficult, and you'll find those in there. Okay, so those are in the beginner, intermediate, and then the advanced sections. Okay, and then if you would like to work on, once you finish the workbook, you're going to take the little page, the 2-page test at the back. I think we're actually finishing this workbook. Yeah, so we're going to take 2 weeks to finish this one workbook. So don't try to finish it all this week. Do part of it this week and the next part next week. Okay, so that's why there's 2 videos. So you can work on 1 video this week and 1 video next week. Don't get behind though, because it can really pile up. So you're going to work on the workbook. And then if you want to take a break from the workbook, you're like, yeah, okay, I get it. Let's actually do some fun stuff. So then there are puzzles that you can do. There's some task cards. There's a scavenger hunt. There's a coloring activity. There's lots of fun things you can do. There's also, so once you finish the workbook and you've done a lot of the activities, there's some stations you can set up around your house and go from station to station, put a little snack by each one, and have some fun reviewing. That's in there as well. And then, I have the math labs for our advanced students. Okay, you are an advanced student if you have completed up through algebra session, I want to say number 4. You've completed that, makes sense, you've done graphing, you understand it, maybe you're working on systems of equations, that's great. All right, so what you can do now is actually do the practical application piece. So this is not for people who are just starting the workbooks for this week and this is new. So the advanced labs are for students that have already completed most of an algebra course and they're ready for practical applications. How do I use this stuff in the real world? So I put together a number of physics labs for you. And so we are going to be doing this. These are really, really fun. So for example, one of them is that you work at a fish store and one of the fish tanks is sprung a leak and you've got to like fill it up. And this is like a real problem that happens in chemistry all the time. Not springing a leak, but figuring out different concentrations, but you don't have the right one that you want. So in this example, you've got different tropical fish. This one's in a 12% salinity. This one's in 25% salinity. But the fish with the leaky tank is only like 20% salinity. So how much of each one do you take out to get the right one so you don't kill the fish? So again, classic chemistry problem in concentration. You've got 2 different concentrations, 2 different molarities of things, and you've got to figure out how much of each one to make exactly the right concentration of the chemical that I need. So this is straight from a college level chemistry course. And so with the fish tank. The other one is you're sitting on the beach. You guys like going to the beach? And you're watching your friends go cliff diving. I don't know about you, but that's not something I'm going to do. I'm going to sit, but because I'm really good at physics, I can time how long it takes you, or maybe you're throwing rocks off of a cliff, to throw the rock from the cliff to when it hits the water. I can not only figure out how tall the cliff is to begin with, but also the speed that that rock is going to hit the water with. And I guarantee you, once you do these calculations, you are not going to want to go cliff diving because it's so scary. And this is why. That's why I would not do it, because I've done the calculations. Okay, so there's an elevator drop problem. So you're working on an elevator, you drop your wrench. Should we be worried? The guy's down there without a helmet on. So these are really practical example problems in physics and chemistry that you get to work in. So I know it says physics, but there should be some chemistry in there as well. Okay, and so we have a lot of fun things for you. Where do you find the advanced labs? Good question. So you're going to find them in, let's go back to the website. We're on Algebra session number 3. And you're simply going to scroll down to the bottom, past the scavenger hunt. You're going to look for the word advanced. See the word advanced? Okay, so this is where I am doing some of the problems step by step. You actually can see, I think, was this the meteorite lab we had? No, okay, so we have 2 different rocks. We have amethyst, we have bismuth. How can you figure out the different masses, the different, using ratios, using fractions, using algebra to figure out some stuff that's missing that we don't have. And then, so this was the live class that I did last year. And then dropping wrenches in elevators, tossing balls in the air, cliff diving, the chemistry lab, calculating concentrations. What's the pressure at depth? I love making underwater robots. But there's been a few of them that have imploded because I didn't do my calculations right. So I'm actually sharing that with you. So clocking dolphins. This was really cool. If you've ever been in an area where maybe you've been boating and then a fish or a dolphin or something is swimming by your boat, and you can figure out the speed and also how far these guys can travel as well. And so that's a really cool challenge, cool lab that you can do as well. The labs are specifically using math in everyday practical applications. Okay, and then the math challenge, somebody was asking about these. There's a different math challenge every single week, and this is an opportunity for you to share math with people that maybe don't like math, or maybe don't really, they're not in algebra class, you're not doing any algebra. This is just something fun, so you can work on your communication skills and your listening skills and collaborating with other people's skills, which is sometimes not easy, right? When you think you've got the right answer and nobody else knows what they're doing, right? So it's important to be able to listen and to share ideas and to be able to come up with something that is even better than you thought it was. So this one is a puzzle. This is digits and circles. And so you can work by yourself and compare answers. You can talk about it. A lot of these things are more teamwork and you got to figure things out. People will have new ideas about things maybe you hadn't thought of. So this is more of a collaboration. There's a new one every single session. So you'll have two weeks to work on this one. Good. All right. And then the solutions to the previous one is below. Okay. All right. How was that? Yes? How about a story? Do you guys want a little story? Okay. I told this one in my, I told this in the fractions one as well. So, all right, so, and I'm wondering, because I'm thinking if you're in algebra, you're also not taking fractions. So, all right, so here we go. You already know about the runaway class, right? The class where I was teaching. You want to see the board? Sure, okay. Here, I'll turn this. Is this what you wanted to see? I think I'm getting a question about that. Okay, if you're having trouble, yes, with your logging into the website, will you please send me an email so we can be helpful to you? So you should not have login trouble. We solved most of those issues, but if you have an old password saved, sometimes that can happen. So send us an email if you need some help. Okay. All right, Civil Aero Patrol. Yes, is a great idea if you want to be a pilot. Excellent question. I love how these are like not math related, but real life related. So yes, Civil Air Patrol, Young Eagles, get yourself in an airplane. And then if you're part of my science program, go to last year's content in May, where we had some flight school, ground school, as well as some aviation, like in-flight training with a flight instructor. So get started now. And if you are interested, if you are close, if you're like ages, I would say 10 and above, the best program for aviation study is still King schools. And so Martha, I forget his name. And so is it Bert and Martha King? So they make the best programs. And so for getting your pilot's license, and they're home study programs. So yay. Okay. Story time. Ready? You have your snack? All right. So here we go. Once upon a time, there was a teacher that was teaching grades 4, 5, and 6. And they really didn't want to learn. They had not had a teacher in that classroom for a year and a half. So it was a private school. So crazy. So I started this story a few sessions ago, I think, a few weeks ago. All right, so we already did the one about fractions, right, where I got them to do fractions. So getting them to do anything was a headache and a hassle because the kids just didn't want to learn. It wasn't the kids' fault, it was the school's fault, but I volunteered to teach while they hired just for a week or two, just to help get them on the right goal. And so I wound up being there for 4.5 months, teaching free of charge. I thought I'd be there a week, maybe 2 weeks. All right. So we're about 2 or 3 weeks in, and the parents are happy, kids are happy, everybody's having a good time. And the parents are like, Aurora, do you think you could teach something besides math and science? And I'm like, yeah, I guess that would be a good thing to do, right? We've been here a few weeks and they still haven't hired anybody. Sure. I'm like, okay, what else should I teach? And they're like, writing. Can you get our kids to write? I'm like, okay. So as we had these weekly sessions, or I think twice a week, just because the class was so out of control. And so so I said, all right, so I'm thinking about how do you get kids to write who absolutely do not want to write? They're like refuse, they scream, they leave, they cry, they whine, they pull all kinds of maneuvers, right? So I thought about it and I said, oh, I have an idea. So I walked into class and I said, hey, today we're going to start a writing assignment. I didn't even get the whole word assignment out. I got protests, I got screams. 2 kids got walked up and like walked out of the room. I'm like, wow, how fun. So I walked in, I said, okay. So I said, I'm going to share with you something I'm going to do. And by the way, if you ever have a power struggle with somebody, one of the ways out of it is not to tell them what to do, because that's where the power struggle, right, gets amped up. Instead, you tell them what you will do. And they can decide, because kids are only going to people are only going to grab at power and control if they have tons of control, it's not going to be a thing. But if they feel like that they have little to no control, they're going to be spending lots and lots of energy trying to get that back. So I knew this. So I walked in and I said, well, here, I'm going to share with you something I'm working on this week. And I said, last time I did this, I won an award, which is true. And I've got it here. I'll show it to you. And I said, here's the challenge. And I'm going to be over there at my desk working on it. If you'd like to work on it, I'll be here and I can help you. I said, it's called 55 Fiction. And it's a local contest that's run in my area. And it's open to people worldwide. And they hold this contest every year in July. And you can submit your things anytime during the year. And then they publish the winners. And the idea is you have to write a story that's 55 words or less. And it could be a story about anything. And it just has to be, the rule is 55 words or less. The title is 7 words or less, and it's not included in the 55. Okay. So I mentioned this, and about half the kids are like, huh. And you could hear the little hamsters going around in the wheel going, I wonder if I could do that. And then, so I was like, this is what I'm going to work on. You're welcome to work on it, or welcome to work on some other assignment that we have for the week. It's up to you. So everybody eventually wanted to do this, right? We had one kid who was being difficult, but besides that, right? There's always one. So pretty soon I'm starting to hear pencil scratch, right? And they're starting to write. And so I'm working on it. And so the kids are starting to ask me questions. They're like, does a period count? And what about like a hyphenated word? And so they're starting to ask questions. I'm like, oh, cool, they're into it, right? So I'm sitting over here, and pretty soon I start to hear grumble, 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 and I'm like, what's going on? And so they're like, yeah, but 50, how many words is 55? And I'm like, well, you're going to have to count, right? Because I can't. So then I hear this, everybody's counting, and they're counting differently, right? So then I hear this, I wrote way too much. Oh, no. And I hear erase, 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 and a frantic erasing, and the paper's ripping because they're pushing too hard, and the papers are crumpling, and they're getting more paper. And so after about 20 minutes of this, the whole class is totally on task. They're working on it. And I'm working on mine too, right? And they're like, did you really win? And I said, yeah, I did. I even cut it out and I framed it. And I won, and they even gave me of course, mine is about airplanes, paper airplanes. And they even gave me like a little picture that they had drawn to go with it, which I thought was cool because I only submitted this part. All right, so I won one year, and I said, see, look, it's a contest. And so I said, so give me your entries. It's free to enter, and everybody can do it from around the world, and you just put it in. It's called 55 Fiction. It's published in the New Times, by the way, if you want to do this. It's called New Times. So they're working on it, and that night I got a bunch of phone calls. One of them was from a lady going, Aurora, what did you do to my daughter? I'm like, oh, I'm sorry. Like, what? Did I do something wrong? And she's like, she told me, this is a girl who doesn't write, doesn't even want to write, right? No interest whatsoever. She goes, Mom, don't bother me. I got to finish this writing assignment. She says, I don't even want dinner. And the mom's like, what did you do? I said, well, I gave her a contest she could enter, and she's like, she's mad at you too because she says she needs more words, but you won't allow her to have more words. She goes, why is that? I said, well, it's not my rules. It's the rules of the people running the contest, right? So like, kids are mad at me. I need more than 55. I'm like, really? You want to write more? That's well, like, oh, shucks. And the kids were like not wanting to write less, they wanted to write more, which I thought was kind of funny. And so anyway, and then I got more phone calls from the parents and saying that you really are stressing my kids out. And I'm like, I'm so sorry, why? And they're trying to get this writing assignment. And one dad dropped the kid off in the morning. He goes, my son spent 3 hours on this assignment. And he goes, I just want to let you know, good job, because he's never been that focused before. So we took them in, and a couple of the kids got published. We sent them in, and later that year, a couple of them got published, and we had like a whole party and everything. And it was so much fun. So long story short, took some kids who had a trigger, right? Let's do a writing assignment. And what are the kids thinking? Why bother? Who cares, right? So I answered those questions indirectly, right? I said, A, there's a contest, so that's the why bother. Who cares? Well, if you win, you get published, right? You can celebrate, maybe have a pizza or an ice cream party with your family, something like that. And doesn't have to include food, but just, the honor of being published, right? I have mine on my wall, which is fantastic, right? So we answered those questions. Normally, what happens with math work like this? Like you do math work or you fill out a math workbook, what does the teacher do with it? They'll take it, grade it, throw it in the trash. So you have to give kids a reason to want to do this, to know that their work matters. So that's why we do self-evaluation. That's why we give you the problems, but we also give you the answer key. That's what they do at the university. We want you to be able to do the problems, be able to check yourself and know that you're getting the right answers, your approach is right, your solutions are right, and know where you're not doing well so you can spend more time there, because you don't need somebody on the outside telling you. We want that to come from the voice on the inside. So we're doing a lot of stuff with this math program. I hope that's coming across. And it's very intentional, very deliberate. And so we also want to make sure your kids know that their work matters. That's why we do the advanced labs that we had, the labs here. So it's not enough just to learn about the inequalities and stuff. How are we going to use this stuff in the real world? And so that's why we have a lot of math labs. And I want to say 90% of the people say that is their best, like their most favorite part of the program, because it really puts into perspective what it is they're doing. So I promised to mention a little bit about fighter planes. So one of the things I had done is I was hired by the Air Force to help work on some new engines they were testing from Pratt & Whitney. And because basically they were putting these things in, so I was a graduate student, they were putting these new engines into their fighter planes. It was an F-15. And for some reason, they just weren't cooperating. They weren't working well. And so the pilots couldn't figure it out. They can't figure it. And so what we did is we made a mock-up. We made smaller versions of them, and we tested them at all different configurations. So not in the air where we can kill people, but like on the ground, so we could find out what's going wrong with the flight, right? What's going wrong with the engines. And we actually took photographs of supersonic air, which is super hard to do. And what we found was if the pilots operated the engines in this envelope over here, they'd be safe. But over here, there wasn't enough thrust for some reason, and that's more of an advanced topic, but there wasn't enough thrust to be able to maintain altitude. So the pilots were doing all kinds of things, because they would do all kinds of crazy maneuvers. That's what fighter planes are designed to do, right? So we were able to tell the pilots, operate here, don't operate here. So we gave them inequalities, basically. It was more dimensional than this. This is a single dimension one. But we were able to give them a range to operate in, because other than that, then the airplane just doesn't work. The engines didn't work the way they wanted to. So these are things that we're using all the time. So if you ever find yourself in a situation where you're in a math class and you don't understand, you need to ask, like, where is this used in the real world? And if somebody says, well, I don't know, but you're going to need it someday, or you'll need it in a future math class, often that's not enough. And the kids are like, oh, great, more math. Lucky me, right? So I can tell you, yeah, you're going to need it in calculus, which is true. You're going to need it in differential equations, which is true. You're going to need it when you look at fluid flow, which is true. But if I can make it so it makes sense to you today, I'm going to hook you so it makes more sense, so you'll want to continue this in the future. Does that make sense? So if you get a math teacher, typically math teachers won't have an engineering background. They won't have a science background. They have a math background. And it's not their fault. It's just they haven't been in the field. They haven't worked as an engineer. They haven't worked on science and engineering projects that actually use math. So that's why the math program, we spent so much time on the labs, because we want you to see, how does this stuff get used in the real world? And I am talking a really long time about this, but I hope it's just because I'm passionate about this. This is why this program is different. I want you to see that it's so much more than just yet another math curriculum. There's so much more built into this that is really going to serve you more long term. All right, we absolutely have to wrap up because you know what's going to happen. People are going to see the recording. They're going to see it's an hour and a half, and they're going to go, what happened in class today? Okay, perfect. All right, so I am going to pause here. Yes, it's called 55 Fiction, not friction, 55 Fiction. You can look it up on the internet and you can find all the rules. It's published in the New Times Magazine, and it's an annual contest that they run. So that's something fun. If that's of interest to you, great, but that's above and beyond. I was just sharing the story about how you've got to answer the what is it and why should I care answers. And so with students learning anything. So in that example, it was writing. All right, yay! Okay, so if you have any other questions, you're going to let me know. Aurora at superchargedscience.com. I will see you in our next class. Enjoy your algebra class. You have Doug on Thursday. He's going to spend 60 minutes doing problem, over and over. And next week, I'm going to do even more problems in class, and Doug's going to do even more. So we have a lot. So if you felt like, this was a lot. I was giving you enough to get started for both the beginner and the intermediate level, and then we're going to continue talking about it next week as well. Okay? So start on your workbooks. Get started. There's no rush. You've got 2 weeks to work through all of the content that I prepared for you. If you have questions, you're going to let me know, and I will see you in our next class. Bye-bye, everybody.